The Math Robots and Sports by Team 1715G. One thing that connects to math in robotics is sensors. There's lots of mathematics involved in robotics. Think of almost any of the clever things robots can do. It's math that makes it happen. A robot can work its way around a room using sensors. And whether they are ultrasonic or detecting light, the sensors turn their measurement of the outside world into numbers. And the numbers represent math. For example, to avoid hitting something in its path, a robot monitors the numbers coming from the ultrasonic detector, like a bat using echolocation. The signal bounced off the object comes back, and the robot calculates the distance to the object. This way, it can calculate the distance from an object. This allows it to move without hitting any obstacles. It also gives the robot data about its environment. Another thing that connects to math in robotics is cameras. Cameras are used in our everyday lives and robots. Robots can also take in sensory information from their cameras and then do something with that information. They behave logically. They avoid a wall or recognizing a smiling face and move it forwards to it. Doing something means moving a certain part of the robot in the proper way. The technical term for this is a motor response. Motor here doesn't refer to an electronic motor, but rather to an actual movement of a part of the robot. Robots can therefore be seen as sensory motor machines. They detect something sensory and react it to it motor because of the math. Coding robots. Coding has to do everything with their lives. It has to do with their computers, robots, and machines. Coding involves math to calculate the speed and other things. When coding robots, you must calculate the angles that robots must turn more math. You must also calculate speed. Math, again, as you can see, math is abundant in robotics. These numbers determine motion, speed, and everything the robot does. Without precise mathematics, such as how many degrees the robot turns, robotics would be next to impossible. Math and soccer. You might think soccer and mathematics have nothing in common. However, you would be wrong. In fact, mathematics has to do with soccer a lot more than you may think. A lot of research has been done over the years about what makes a perfect football. Cumulative occurred mathematics research has shown that the smoothness of a soccer ball affects the spin and the speed of its flight. In 2006, the familiar 32-panel soccer ball was changed to have fewer panels, which caused the ball to have a less spin and thus move much faster. To overcome this, researchers added dimples or small impressions onto the ball to create a less drag. The design of a soccer ball continues to change, given increasing information based on mathematics and physics research, and now has even fewer panels than in 2006. Math and soccer continued. If you still believe that soccer and math have nothing to do with each other, then what I told you, you could actually win at penalties using statistics. Researchers from the University of Amsterdam in the Netherlands have studied World Cup penalty shots and concluded that statistically, goalkeepers are twice as likely to dive in the right when their team is behind. Although the reason for this is unknown, it is mathematics again that has led to this discovery that could end up changing the outcome of a game. Researchers at Brunel University have identified that the angle which maximizes the distance of a throw is around 30 degrees. Anyone learning mechanics will know that 45 degrees is an angle which will maximize the distance that the projectile travels when launched at a certain speed, that is, usually. Researchers have, however, shown that soccer players can usually throw at higher speeds from lower angles, meaning that the best angle is around 30 degrees, not 45 degrees, as you have may thought. In conclusion, math and robotics are both related and interconnected. Without math, robotics would not be possible. And this is the end of our STEM project. Thank you for your time and energy for listening to our STEM project. And all that implies, written and edited by Abhishek Vijay, video produced entirely by Ryan Jarbanga, All predictors founded by Raymond Collis. Thank you for your time. I hope you enjoy this video.